Okay. Yeah, my name's Josh Lawrence, working at Heriot in the Lyell Centre, and I'm harking back to some of the topics that Dan covered in the first talk of this session, but about some work that Paul and I have been doing, and some of the challenges we've been dealing with trying to sample around offshore structures, and some of the innovations and the marine autonomous and non-autonomous systems that we've been using. So to give some context to the technology, we're actually sort of bridging InSight and EcoWind with this work. So in the FISHSPAMMS project, which is fish spillover production and aggregation at man-made structures, that's a project that ends this year, as we know, in the InSight program, and we're looking at fish distributions around oil and gas infrastructure in the context of decommissioning, as we're all aware. And the main question that we're hoping to answer or to look at evidence for is whether there's aggregation of fish at these structures and whether there's evidence for elevated production. The next sort of stage of the technology work is on the EcoWings project in the EcoWind program, which is ecosystem change, offshore wind, net gain, and seabirds. And that runs until 2026. Where we'll be looking at fish distributions in and around offshore wind farms. And then, as well as fish data, we're looking to compare to seabird distributions, looking at spatial overlap and that sort of predator-prey spatial dynamics. However, as has been mentioned, there are challenges for traditional research vessels working around these structures. So there's issues of access that Dan touched on, both in terms of legality. So oil and gas platforms in the North Sea have 500-meter safety zones, which are essentially closed areas to all but sort of their own vessel traffic. And that's because of the risk to that sensitive infrastructure. And then around offshore wind farms, it's a bit, can be case dependent, but particularly during construction, there are issues around sort of safety and getting in the way of activities. There's also issues for the safety of crew. So in the EU, there's about 2,500 accidents or injuries reported at sea every year. There's also issues, anyone who's tried to do or arrange marine surveys, vessel availability and cost is a big factor to consider. So I'm using the Scottish Government research boats, the Scotia and Alba Namara, as sort of examples, but their costs total about £5 million a year to get a combined 500 days of sea time. And as Dan mentioned, carbon footprint, Scotia and Alba combine to use about 1,800 tons of diesel every year that I have the data for online. So yeah, a large carbon footprint. However, we think that autonomous or uncrewed vehicles offer some solutions. So to counter the traditional problem of site access and risks, essentially the small size of some of these autonomous and uncrewed vehicles means there's essentially zero risk to any infrastructure. You make it safe for crew by having no crew on board. Vessel availability and some of the flexibility that these offer, as the field grows, there are more of these vessels available, and some of the advantages that I'll touch on later are that they're very flexible in how they can be mobilized. So you can launch them near your survey sites. The high costs of traditional vessels are countered by much lower operational costs of these autonomous and uncrewed vessels. And the carbon footprint is much, much lower. So that stat that Scotia and Alba use 18,000 tons of diesel per year, our USV, if we were to survey continuously for a year, which would actually give you about the same amount of survey time, would use less than 3 tons of diesel. So it's significant savings. Our experience of USV surveys to date, we did one survey in 2021 where we were working with a company called X-Ocean. You can see in the video that it's launched from a trailer, so that, as I mentioned, the mobilization is completely flexible. Because of the small size of the vehicle, we're able to get up close with it and calibrate our equipment, which is really important for getting accurate measurements. The boat surveys at about 3.5 knots, which isn't as fast as a larger ship, but is perfectly usable. And during this survey, we surveyed 4 oil platforms and an offshore wind farm over the course of a 5-day survey. Just to give a sense of what that survey process or the experience is like, these are some screenshots from the remote pilot sort of camera system And you can see there's 4 aft, port and starboard, and this is us right up close to an oil rig. And we were able to get to within about 20 meters of the rigs without any risk to the rig itself. Here's a screenshot showing through a wind farm. You can see the turbines sort of all across the horizon. We didn't go right up close to the turbines, but we did put a line through the middle of a wind farm. And you can see over on the left, you've got sort of pilot information with vessel details and data, and then the sort of chart plotter view on the right. However, we did have some problems with that process and those surveys. The vehicle had limitations on the range from shore. It had limited endurance. We had some issues with data quality, and because we were essentially a customer of Xocean, who are a commercial enterprise, there was a lack of control that we had about some aspects of the logistics. We had a longer survey planned for 2022, but some of the problems got worse, and a change to the electrical system actually meant that the data was unusable, so we had to cancel that survey. We've since taken matters into our own hands and are now working with the National Robotarium, developing Sea Enduro, which is our own USV that we own at Heriot University. And this is very similar to the Xocean platform, so it's small, again, launched by a trailer, about 500 kilos and 4 by 2.5 meters, so another really small platform. It does have some modifications needed, though, to be survey ready, and as well as that, we have some plans for some extra vehicles. We have an AUV as well. This is quite a lot smaller than Dan's Boaty McBoatface. It's about 3 meters long, and because it's modular, it's very flexible. Weighs about 40 kilos, so we just launch it by hand off a small boat. And this is it at the surface, so it has a little orange antenna, and that's how it checks in with its, to confirm its location and check in with mission control, and then it's capable of operating at about 100 meters and has an upwards-facing echo sounder. So that means that it fits in nicely with a planned multi-platform survey we're going to be doing in some wind farms. And as I mentioned, eco wings is fish and seabirds being considered. So we've got aerial surveys from a plane looking at seabird distributions. We'll then have the USV, the uncrewed surface vessel, surveying fish in the water column and down near the seabed. And then simultaneously, we'll have the AUV surveying fish at about 30 meters, looking up towards the surface to see fish that the USV can't see. And this gives us a full surface to seabed data collection. The area this is planned is in the sort of area just offshore from Edinburgh and around the Isle of May. These green polygons are some of the wind farms there. Overlaid there are the plane transects, so the seabird surveys. We're going to fit our USV transects across that, hopefully passing through at least 2 wind farms which are there and some planned wind farms. And then the AUV, it does have a shorter endurance, but that will do some similar transects or the same transects as the USV, so we get that full water column survey. With this in mind, the USV does have certain requirements. So the plan is for it to work fully over the horizon, but without a mothership, but then in a non-autonomous mode. So as I said, it's piloted in real time over a satellite link. It needs to operate around structures. We'll need more than 4 days of endurance. It needs to be safe for other marine users and for infrastructure. And as part of that, we need the MCA, the Maritime and Coast Guard Agency, to be on board, or not on board. The modifications that we need for our USV, there's a few problems that we had, and therefore the solution. So originally it was only battery powered, so we're fitting or have fitted an onboard generator. For connectivity over the horizon, we've added Starlink. Obviously, a vessel of any size does pose some navigational risk, so we've had to upgrade some of the lights, radio, and cameras. We have some issues with the vessel control software, where it was essentially an over-the-counter USV and software, so we're considering a refit, but that's going to be an extension or an additional bit of work. And there are still some hoops we have to jump through to operate around these structures. So there's bureaucracy and risk assessments that need doing. Oh, 1 minute. As I mentioned, we need the MCA to sign off on the vessel. And part of that is that essentially there's no grey logistical area or legislative area for research activities. We basically count as a full commercial vessel. And there's this legislation, the Workbook Code 3, that has huge numbers of requirements for safety, safety equipment and control software. So it's arduous but necessary, because the most important thing is that it's safe. The modifications are complex because the main benefit of these systems is that they are small, but that does bring challenges with the small form factor, and there are costs up front in terms of time and money. And additionally, we are still having some difficulties getting access to sites. So despite EcoWind putting out some guidelines for getting access to the wind farm sites, there have been some developers who've been hesitant, particularly around construction, even though technically they should allow third-party access. And there's also some hesitations that we've heard around the fact that it's novel technology, but we're hoping that risk assessment processes and demonstrating a track record will get over those concerns. However, we are optimistic for the future. As I said, our vessels are very nearly ready for surveying. This is footage of the USV trials on Loch Earn. We've already got some data that Paul will be talking about later, and we're really excited to start getting some of these new data sets. We've already got plans for more developments and future applications, so we're planning to add a hydrophone so we can listen for marine mammals, an ADCP to look at hydrodynamics, possibly a drop camera to look at species ID and sizing and maybe bottom substrates. And also we're planning to grow the fleet. So we've already got a second USV, which when we finish developing the first one, we'll get started on. But just to emphasize that the real three main benefits of this sort of equipment are the low costs, operational costs at least, low carbon footprint, and low risk to infrastructure and other marine users. And that is everything. So I didn't have to get the stop sign.